Hello, my name is Martin Hürzel. I'm presenting the poster on engineering fair machine learning pipelines, which comes with a paper at RAI at ICLR. My collaborators are Kiran Kate and Pari Ram. We are all at IBM Research in the US. Our paper makes three contributions: fair stratification, fairness patterns, and an open source library called LALE-lib-AIF360. The problem that fair stratification addresses is fluctuations in dataset composition, which can actually cause misleading conclusions during testing. And fair stratification addresses this problem by stratifying not just along the outcome, but also along all intersections of the privileged or unprivileged groups. And while this doesn't make your model more fair, it gives you a more stable assessment of the fairness of the model. Here's how you use our fair stratification from Python. First, you declare the fairness information that corresponds to the dataset you care about. And this is declared as a simple JSON format. Second, you can call fair stratified train test split, which is a Python function that returns the splitted data, and it takes in this fairness info that we just declared. This function is compatible and has a similar API as the corresponding scikit-learn function train test split. And third, instead of just splitting into train and test, you can also do a cross-validation split, again in a scikit-learn compatible API. So just like scikit-learn has a k-fold cross-validator, we provide a fair stratified k-fold, which you can then use with other scikit-learn functionalities, such as, for instance, grid search. Now, our second contribution, fairness patterns, is motivated by the problem that data preparation can interfere with fairness mitigation. And therefore, we believe that you should be defining a joint pipeline that includes your data preparation, as well as your classifier or regressor or other estimator, as well as the mitigator as operators all in the same pipelines. And again, here's the Python code for how you can use our fairness patterns. In this case, the fairness pattern is a pre-estimator fairness pattern. So that means that the mitigator, in this case disparate impact remover, takes place before the estimator, in this case a logistic regression. And to make that work with data preparation, we are passing in a data preparation subpipeline to the disparate impact remover, which is the entry point for the fairness pattern. This is only one example. In the paper, we are also discussing other patterns that apply to other approaches for mitigation, including in-estimator mitigation and post-estimator mitigation. And in fact, we provide wrappers for 10 different mitigators. Now, if you write the Python code on the left, what you get is the machine learning pipeline on the right, which includes the data preparation pipeline shown in white that you defined yourself, but it also puts in the appropriate topology for the disparate impact remover, including the protected attributes encoder. And this is important so that you can stick with the usual scikit-learn API, where you just pass in train X and train Y as pandas data frames, and you don't have to provide additional inputs for the fit method in the end. And then you can just pipe the result of the entire pre-estimator mitigator pattern into your favorite estimator. Here we are using logistic regression. The third contribution of our paper is that we made everything available as an open source library, LALE-lib-AIF360. And down here we are providing some links for finding out more about the source code, reading a demo notebook, looking at the API documentation, and of course reading the paper that gives this poster the title.